Hello everyone. Starting today, we will study the electrical machinery course. Today, we will first talk about the first chapter of transformers. The first section, basic knowledge of transformer. The working principle of transformers. First, let's understand the transformer and its application in power systems. The transformer is a static electrical device that transforms AC powers of one voltage level to AC power of another voltage level at the same frequency, based on the principle of electromagnetic induction. The transformer is a static electrical device, not a rotating one. Here, we need to emphasize 2 points. First, the transformer is a static electrical device. It does not rotate. Second, the transformer changes the voltage level of AC power rather than converting it, and it does so at the same frequency. Electrical energy from production to consumption generally goes through 4 stages: generation, transmission, distribution, and usage. For power systems, the first stage is generation, which is completed in power plants. Due to installation conditions and speed limitations of generators, the maximum voltage of generators is generally not more than 20 kilovolts. Secondly, step-up transformers are used to increase the voltage from long distance, high voltage transmission of electrical energy. After being sent to the load center, the voltage is stepped down to 10 kilovolts through regional substations and then delivered to distribution transformers via 10 kilovolts distribution lines. Finally, the voltage is transformed to 380 volts by distribution transformers for use by electrical consumers. In the process of transmitting and consuming electrical energy, transformers are used multiple times. In electrical energy measurement, control, and certain special electrical devices, various types of transformers are also extensively used. The main functions of transformers are voltage transformation, current transformation, and impedance transformation. First, voltage transformation. For example, in power systems, the transformers used are for voltage transformation. Voltage transformers convert high voltage to low voltage. Second, current transformation. For example, current transformers convert large currents to small currents. Third, impedance transformation. For example, in small signal circuits, transformers are used for impedance matching. Next, let's look at the basic working principle of transformers. This principle is the law of electromagnetic induction. Let's first look at this diagram. When voltage U1 is applied to the primary side, a current I1 is generated in the primary circuit. I1 flows through the coil around the iron core, creating a magnetic flux phi. The changing magnetic flux phi induces an electromotive force E1 in the primary winding and an electromotive force E2 in the secondary winding. This is the law of electromagnetic induction. The main components of a transformer are the iron core and the coils wound around the iron core. There are 2 windings. Set the number of turns on both sides of the winding are N1 and N2 respectively. According to the law of electromagnetic induction, in terms of electromotive force and magnetic flux, compliant with regulations in the positive direction, under the premise of the right-hand spiral rule, primary side electromotive force E1 equals to minus N1 times D times phi divided by D times T, and the electromotive force on the secondary side E2 equals to minus N2 times d times phi divided by d times t. Since the two windings are wound on the same iron core, the magnetic flux through each turn is the same, and thus the rate of change of magnetic flux is the same for both windings. According to the law of electromagnetic induction, the electromotive phi force per turn is the same for both the primary and secondary windings. The electromotive force in each turn of the primary and secondary windings is proportional to the number of turns. By extracting the induced electromotive force E2, we obtain the output voltage U2 of the transformer. When the load is connected, there is a current I2 flowing through it. Thus, the power is transmitted from the primary winding through the transformer to the secondary winding and then to the load. The ratio K in the formula is called the transformation ratio, or simply the turns ratio. The ratio of electromotive forces between the primary and secondary sides is approximately equal to the ratio of voltages between the primary and secondary sides. Therefore, by changing the ratio of turns between the primary and secondary windings, we can change the voltage. If N1 is bigger than N2, it is a step-down transformer. If N1 is smaller than N2, it is a step-up transformation. This is the basic working principle of transformers. Next, we have a few concepts to emphasize. We call the winding with higher voltage the high voltage winding, and the winding with lower voltage the low voltage winding. The winding that inputs electrical energy is called the primary winding, or the primary side winding. The winding that outputs electrical energy is called the secondary winding, or the secondary side winding. It should be noted that the primary winding is not necessarily the high voltage winding, and the secondary winding is not necessarily the low voltage winding. This depends on whether the transformer is a step-up or a step-down transformer. There is an after-class thinking question. Can transformers change DC voltage? The answer is no, because the function of transformers is to change the magnitude of AC voltage. The principle is the law of electromagnetic induction. Transformers use their primary coil, secondary coil, and the internal magnetic conductive silicon steel sheets as electromagnetic carriers to change the voltage level according to the law of electromagnetic induction. However, the voltage of DC voltage is constant and does not produce an alternating magnetic field, so transformer cannot change DC voltage. In this lesson, we briefly introduced the application of transformers in power systems and the working principle of transformers. We also reinforced the concept through a question. That's all for this lesson. Thank you for watching.